Decided it's going to work today. All right. So when we did this before, I think we probably wrote somewhere on the unit circle that to find the sine of an angle on the unit circle, you just use the y coordinate. And to find the cosine of an angle, you just use the x coordinate. Now what's new today is we're going to find the tangent and the cotangent. And they're not as easy. So we could do those shortcuts for sine and cosine because you divide by r, and r is just 1 on the unit circle. Well, tangent doesn't use r. So how do you find the tangent using x and y? It's y over x. And so what we're going to do at each angle, we're going to take the y coordinate and divide it by the x coordinate. Or if that x coordinate is a fraction, we would multiply by the reciprocal of the x coordinate. That's going to give us the tangent of theta. Okay, now I altered your graph paper a little bit. I took off some of the lines that you don't need to make this a little less crazy. There are some gaps in there, but I think it's going to make it easier for us to do it this way. Okay, so we're going to start with the angle that is 0. If we're going to do the tangent using the unit circle, we're going to take y and we're going to divide it by x. And what are we going to get? 0. So that's the point 0, 0. So make sure you're on the side that says tangent, please. Okay, so that's 1 point, and we're going to keep on going. And hopefully we're going to see a pattern pretty quickly, so we won't have to do this a ton. All right, then we're going to go to pi over 6. We're going to take the y, and we're going to multiply it by the reciprocal of x. So I'm going to actually write that down. You don't have to if you don't want to. So the y is 1/2. And we're going to multiply it by the reciprocal of x. All right, so that gives us 1 over the square root of 3, which isn't on our y-axis, but is there something that equals that on our y-axis? Yeah, good. All right, and then for pi over 4, if I take the y and divide it by the x, what should I get? Just 1. Anytime you divide something by itself, it's just 1. Whoops, put that in the wrong place, sorry. Okay. And then for pi over 3, I'm going to take the y and multiply it by the reciprocal of the x. So if I do square root of 3 over 2 times 2, what do y'all think? It's just the square root of 3. All right, and then pi over 2. So pi over 2, I'm going to do y divided by x. What do y'all think? Undefined. And how do we do undefined on the graph? Vertical asymptote. Good. Okay, so that's what we would do all the way around the unit circle. But I think you're going to be able to see the pattern once you keep going. So for the next one, we're going to do y times the reciprocal. So this time it's going to be negative square root of 3. So you guys finish going around the unit circle with that, please. So if we connected these points, that is one period of tangents. So we're going to have 2.5 periods graphed on this paper. Okay. And so if this is one period, it falls in between these two vertical asymptotes. What is the length of a period of the parent function of tangent? What is the length of the period of this function if it falls in between those two lines? 1 pi, right? So it'd be half of a pi plus another half of a pi is going to be a whole pi. So the period is pi. What about the amplitude? It's not going to have one. And we already kind of filled that in on that chart. But because it's going to keep getting taller and keep getting shorter or smaller, there is no maximum or minimum, so we can't have an amplitude. So that's tangent. All right, let's see what happens with cotangent. Now, I don't want to do it on the same side because they kind of cross each other and it gets kind of confusing. It worked for like secant and cosine because they just bumped each other, but this isn't as good. So turn on the cotangent side, please. And we're going to do the same thing, but instead of doing y divided by x for cotangent, we're going to do x divided by y, or x times the reciprocal of y. And we'll start with the angle 0 radians. So we're going to do x divided by y. What do y'all think? X divided by y is undefined. So the first thing we're going to graph is actually a vertical asymptote. Okay. And then for pi over 6, we would do y. I'm trying to remember. We're going to do x times the reciprocal of y. So it would be the square root of 3 over 2 times 2, which should be the square root of 3. Okay. And then for pi over 4 and all of the pi over 4s, there's a 3 pi over 4, 5 pi over 4. They're all going to be 1 or negative 1 because you're dividing something by itself. So that's going to be either 1 or negative 1 depending on your signs. Okay, and then this one should be square root of 3 over 3. Okay, and then for pi over 2, you're going to do 0 divided by 1, 0. So I'm guessing you guys can guess the pattern here. We could go through all of them if you wanted to, but this is just to help you get an idea of what the cotangent graph looks like. Okay, so this is 2.5 periods of cotangent. So this would be 1 period of cotangent. How long is it? How wide is the period? Pi. So tangent and cotangent, the parent functions have a period of pi. Unlike all the other 4, that the original period is 2 pi. Right, and then this also does not have an amplitude. Now, one thing that I tell my students, I don't know if it sticks with them or not, but to try and keep the difference between tangent and cotangent in their head, I say that cotangent is a sad graph because it goes down from left to right, and then a tangent is a happy graph because it goes up from left to right. I don't know. Do you think there's anything that you can do to tangent to make it sad? Negative. Negative tangent is sad. So happy, you're going up from left to right. Sad, you're going down. Is there anything that can make cotangent happy? Negative cotangent is happy.
Negative tangent is the same as positive cotangent.
Not exactly. It does. It is upside down. But the asymptotes are in the wrong place. So it is. It is a negative cotangent shifted over. But they are reciprocals of each other, not just reflections of each other. Exactly. Okay. Let me get you guys the note sheet. All right, so on here I have the parent functions for tangent and cotangent, but I didn't label them as much as I want to. I just took this from my graphing calculator. So let's put extra things on here. So let's label the x-axis x and the y-axis y on both of them. And then they both on the x-axis are going from negative pi to pi. And on the y-axis, they're going from negative 4 to 4. All right, so the little halfway between points are pi over 2 and negative pi over 2. Okay. So one thing that is really hard to remember about tangent is the first period of a tangent, it doesn't start at 0. All of the other ones do. It's different. So try to be careful. All right, so on the first example, I've mixed in some tangent and cotangent with sine and cosecant. The only thing that's different about what you do on these that we haven't been doing like the last 3 days is that the tangent and cotangent have shorter periods. So it's the pi over whatever, not 2 pi over. Oh, we need to fill that in. Sorry. Let's do that too. So on your little half sheet, when we're doing the period of tangent and cotangent, it's pi over the absolute value of b. Sorry. Now they both have none for the amplitude, just like secant and cosecant. And the phase shift is still done the same way, or the horizontal shift, and the midline is still exactly the same. So the only thing that's different when we're doing these characteristics is the period. So on A, when we go to find the period instead of doing 2 pi divided by the number multiplied by x, we do pi because it's tangent. All right. And then horizontal shift, exactly the same, is going to be right. And how many? Why do we not have to divide? It's already been divided. It's already been pulled out. So when it's like this, don't worry about dividing. All right, what about the midline? Yes. It's actually y equals 2, but you can just put 2. No, it's not. X equals 2 and y equals 2 are not the same. It's all right. Then that's a slanted line. X equals 2 is a vertical line. Y equals 2 is a horizontal line. Y equals X is a slanted line. All right. Anyway, let's look at the next one. Let's find the period, the horizontal shift, and the midline. Right, so because it's cotangent, when we go to do the period, it's going to be pi divided by the number being multiplied by x. So what would that simplify down to? 2. Do I need to divide on the horizontal shift? Yes. So it hasn't already been factored out, what's being multiplied by x. So we have to do c divided by b, which we just did. So it's 2 units, which direction?
Right.
To the right. Now, if you don't know these things, like if they're answering these questions and you have no idea what's going on, you probably need to look at this guy right here. All the things we're doing can be found on this piece of paper. All right. And then what if there is no shift up or down? What's the midline? 0. Okay. Y equals 0 or just 0. Okay, I'm going to do one more with you. I'm going to let you guys do one on your own. Okay, so this one is sine. So it's doing like the old days when all we knew was 2 pi divided by the number times x. So the period is pi over 2. Does this one have a horizontal shift?
No.
How do you know?
There's nothing added or subtracted.
Exactly. There's nothing added or subtracted inside parentheses. There is no horizontal shift. All right, what about the midline? Yes. All right, you guys try D on your own, please. All right, so double check yourself with what I got, or double check me too. You never know. Okay, so yes, ma'am.
So does the number that's usually the amplitude just do nothing?
For tangent, cotangent, it actually makes it like if that number that's multiplied is bigger than 1, it makes it like have a steeper slope. And if it's less than 1, it makes it have a less steep slope. All right, any other questions? All right, so let's do a couple of graphs. All right. So for tangent, really, all we need to figure out, because the ones I'm giving you, aren't going to have a shift left or right or up or down, really. So we really just need to know the period. When we know the period, we can do it. So for the period, remember, because it's tangent, it's pi divided by pi over 3, or just 3. All right. So tangent, first period, does not start at 0. So what we're going to do is just draw a x and y axis for tangent. Whoops. And we're going to have 2 vertical asymptotes. And the distance between those 2 vertical asymptotes needs to match the period. So where do they need to be? 1.5 and negative 1.5. Good. How'd y'all get those? Half the period. So it's a half a period on the left and a half a period on the right. Okay? Now, as long as there's not a shift left or right, it's gonna cross at the origin. And then since it's a positive tangent, is it happy or sad? Happy. So we're just gonna draw a little happy graph. That's it. Now, cotangent is different. Cotangent, the period starts at 0, so don't expect to do cotangent just like we did this, because I promise you it's different. Okay, period is 4, so it's pi divided by pi over 4, which is 4. All right, now for cotangent, we're going to draw axes like this, as long as there's not a shift. And the left side of the period is just like on tangent, is going to be a vertical asymptote, and so is the right side. So we're going to fit 1 period of cotangent in between those 2 asymptotes. What does the width of these need to be? Right. So this needs to be a 4. Right. And then we just need to know one more thing. They're going to cross right in the middle of those 2, which is going to be 2. Right. And then I have seen questions that kind of bring up what Lindsay was asking about the steepness of these. And so I've seen a question where it was just like, which one of these is 2 cotangent of whatever? And there was one that was steeper than the other one. So just know that if there's a number here that's bigger than 1, it's going to make the cotangent curve be steeper than normal. So if you're comparing to trying to figure out which is which, the bigger the number, the more steep. And then this is going to be sad. So you can draw it steeper than normal if you want to. We're not really labeling the y-axis, so you can draw it however you want to, as long as it's sad. That's it. So there's a lot more to the sine and cosine and secant and cosecant graphs than tangent and cotangent, but it's a lot to keep straight in your head, I know. Do you all have any questions? All right, your assignment is a worksheet. I'll give it to you.